Hello, I'm Hannah Donnett with the Collaborative on Health and the Environment. Change is bringing you the latest environmental health science through our partnerships, calls, webinars, science serves, publications, and social media. I would like to welcome everyone to today's CHE EDC Strategies Partnership webinar, which is titled DDT Exposure in Grandmothers Linked to Obesity, Earlier Periods and Granddaughters, New Meaning of Persistence for an Environmental Chemical Banned 50 Years Ago. Our moderator is Jerry Heindel, founder and director of Commonweal's Healthy Environment and Endocrine Disruptor Strategies, or HEEDS. We will leave time following the presentation and conversations between our moderator and speaker for a brief Q&A session. You may type in questions through the Q&A feature available at the menu bar at the top of your window at any point during the presentation. After the presentation, we will have a Q&A. Our moderator will read out questions for our speaker to respond to. We'll get to as many comments and questions as we can during the Q&A period. For those of you who have called in on the phone, we have posted slides to accompany today's webinar on our website. You can download these by going to healthandenvironment.org. Please scroll to the bottom of the page and select today's webinar. On the webinar page is a link to the slides. Everyone on the webinar right now is muted, with the exception of our moderator and our speaker. This webinar is scheduled to last for 40 minutes and is being recorded for our call and webinar archive. With that, I'll turn things over to you, Jerry.
Well, thank you very much and welcome everyone. We're very pleased today to have as our speaker, Dr. Barbara Cohn. Barbara is an epidemiologist and has her PhD degree from the University of California at Berkeley. Indeed, she's really a Berkeley girl, having gotten all of her degrees, I understand, from Berkeley. Since 2001, she's been the director of the Child Health and Development Studies at the Public Health Institute in Oakland, California. The Child Health and Development Study is a groundbreaking study which originated way back in 1959 to shed light on the various factors impacting health during pregnancy and early childhood. And during this webinar, Barbara will explain more about this unique cohort. So in addition to that work, she also directs a research program examining how pregnancy protects against breast cancer in mothers and children to identify natural protective mechanisms that can be used for disease prevention. She also investigates whether exposure to environmental chemicals during pregnancy affects a variety of disease outcomes later in life, including obesity, immune dysfunction, reproductive health, cardiovascular diseases, diabetes, neurodevelopment, cancer, and health disparities, both in the mothers and the children across the lifespan. So in addition to her own research program, she consults with researchers around the globe on the use of this child health and development study data for health research. So thank you for agreeing to talk to us today, Barbara, and I turn the podium over to you.
Thank you very much for having me. I'm very excited to share this study with you today. It is definitely 60 years in the making. And I was only 8 years old when this study started, and I thought that was truth in advertising. So let's go. So today I'm going to talk about 7 different things as quickly as I can: the significance of this study, the power of a pregnancy cohort for research, a little bit of background about DDT, the study methods for this particular study of grandmother DDT levels and granddaughter obesity, the results of this study, the prior human and experimental literature that is related to these results to put them in context. And finally, I'm going to show you, try to integrate all the DDT related results that we have done in the CHDS and provide some conclusions that you can take away with. So first is the significance of this research. And this is the first article that I'm aware of to report on a human association of a grandmother exposure to a persistent organic pollutant, an environmental pollutant like DDT. It is also a chemical that is known to be an endocrine disruptor, which means that it messes with the activity and function of your endocrine system. and its relationship to granddaughter health and third generation health in humans has never been investigated before, not just DDT, but any other such environmental chemical. So this was a very significant study, and it was 60 years in the making because it takes that long for human generations to go from 0 to 3. So what's the power of a pregnancy cohort, and what is this thing, the child health and development studies? Exposures to a pregnant woman impact 3 generations simultaneously. The mother, who is the first generation, we often call her the F0, is adapting to pregnancy in almost every single one of her physiological systems, and they are vulnerable at this time. The fetus that's growing in her uterus is developing all the organs and all the systems that it will ever have ever in its life. And it's also vulnerable to errors at this time. But inside the fetus, in this case, we'll just assume this is a female fetus, are all the eggs, all of the reproductive cells that will eventually become the third generation, the grandchildren. So we have the mother F0, the fetus or the daughter F1, and the granddaughter or F2. And of course, this can continue forward. So you can see that a pregnancy study is a very efficient way, especially if you're concerned with critical windows of development and whether those critical windows make each one of these stages of life, the mother, the embryo or daughter, the germ cell or eventual granddaughter, at risk for a subsequent health problem. So CHDS was initiated in 1959. We enrolled 20,000 pregnancies by 1967. This was an amazing feat. And these are actual children who gave permission. What the children born into this cohort in the 60s looked like when they were about 5 years old. And just to put this in context, I want to tell you how old these people are now. So the parents generation, the original pregnant women who were in the cohort are in their 80s. Their children are in their 50s and 60s, their daughters, and their granddaughters have a great span of age because of the way people had babies in the 80s and 90s, but they're an average age of about 20 now. I've lost my cursor, there they are. And then there is the fourth generation that is now being born. So just so you know, while this feels like an ancient study, the people in it are the current people who are alive and around you. They represent who we all are now today. We recruited 98% of eligible families, reflecting the 1960s and the willingness to contribute to public health research. That was a wonderful thing. And we have interviews that provide perspective predictors in many, many different domains, many of which I'm not going to cover today, but I'm letting you know that we're not limited to only a few variables. We have medical records for accurate phenotype that we were grateful to be able to get to, and linkage to the California Cancer Registry that gives us cancer outcomes for the mothers and for the offspring generation, the grandchildren being somewhat too young to think about yet. We had examination studies that provided further life course perspective at multiple ages, and we're going to be talking about one of them today. And we lastly have blood samples that have enabled assays for biomarkers and environmental exposures directly, for example, in the blood of the pregnant women that enrolled in the 1960s, that let us see what they were exposed to, what their embryo or daughters were exposed to in utero, and what their future grandchild was exposed to as a germ cell or as an egg cell in utero. So why does DDT matter? Now, DDT was a pesticide. Most of you will have heard of it, but also you will know, at least in most Western countries, DDT has been banned, although I remind you that it is still in use in Africa and some parts of Asia. So why does it still matter if it's banned? So you probably have seen this picture before, but DDT was one of the most ubiquitous man-made synthetic environmental exposures ever in the world. There is probably not a single human person alive who was unexposed to DDT because you could have been exposed directly in the 1960s if you were alive then, as an embryo in the 1960s if you were in utero then, or as a grandchild in the 1960s, as a germ cell if you were if your mother was born in 1960. So this means everybody. So banned or not, the question is whether or not in a critical window of development, whether this exposure means anything for current health. So today we have to talk a little bit about the kinds of compounds that were in the actual bottle of DDT that got sprayed. So DDT can exist in several different forms having to do with its chemistry, but the insecticide had a chemistry that is designated as PP DDT, this purple stuff here. And when it's manufactured, it isn't pure. Sometimes it likes to change its stripes a bit and move around, and it can take a different form. This is the form called OP-DDT. And in the bottle of DDT, about 15% of what was in the bottle was this contaminant. Over time, the regular insecticide gets turned into a metabolite called DDE. It's like a byproduct. And this stuff is the most persistent compound, and it's still in the environment. You can still get exposed to this and probably are being in the food chain and in other ways. And however, this compound, the OP-DDT compound, is the one that disappears most quickly, both from your body and the environment. And so it's very much a marker of recent or exposure to the commercial insecticide. So we're going to talk only about OP-DDT today, because this is the contaminant that we have found repeatedly is related to health results from in utero exposures or exposures in early development. So a little bit about our study methods. We had a 3 generations breast cancer study that was funded by the California Breast Cancer Research Program. And this is a diagram that gives you a little bit of information about how how this new study was related to the old. So here are the moms, they're pregnant, 59 to 67, and they're moving forward in time. This ends at 2013, but didn't have to. And these are their children. Their children were born between 59 and 67, and there were 20,000 of them. And they moved on through life. We didn't have the opportunity to observe the pregnancies of the daughters that were born here. But by 2010 and 2013, we had funds to revisit the daughters and their daughters. These are the granddaughters right here. And when we did this new visit, we did a home visit. We did measurements on the daughters who are age 50 and the granddaughters who are an average age of 20, all at the same time in their households. We measured blood pressure and their waist circumference and how much and their height, so that we could learn. And we took also biospecimens. We're not going to talk about that today. But in any case, it is these granddaughters and their paired mothers and their paired grandmothers that we're going to be talking about today. So we call these triads: grandmother, mother, and daughter. So just a few things to say. There are about 258 triads in the obesity outcome studies that we're going to talk about today, and 235 triads in the age at menarche study that we're going to talk about today. And that I wanted to point out that the study size is always limited by funds, but we worked very hard on this, and the study sample is very highly comparable to the demographics for the family backgrounds of people who are in the CHDS. Of note, I want you to mention that 30% of this sample were Black, and this is very consistent with the population of Alameda County in the 1960s. We've had very, very good cooperation from the participants' families from the Black population, which sometimes can be more reluctant to participate in research. We've been lucky we have had less of a problem with that, probably because of the legacy of the study. So we had to define granddaughter early menarche in a way that we could study it with the sample size we had. So we chose the bottom 25% of the menarche ages that were reported by the granddaughters, and that was age 11 or less. So we had to consider some other factors besides DDT that might influence the granddaughters' obesity, and the granddaughter's age at menarche. And mostly these were the grandmother and mother's own body mass index or fatness, their race, and their own age at menarche. But finally, the other issue that we wanted to address was whether the grandmother's herself overweight modified the correlation of the DDT in her blood with her granddaughter's obesity and menarche. The reason we were interested in this is that we know the DDTs are stored in fat. And we also know that adiposity or fatness can modify the metabolism or transfer of pollutants to the fetus. And so we needed to look at this as a possible factor that might change or alter the relationship of DDT in the grandmother's serum blood to the granddaughter's outcomes, health outcomes at age 20. So here are our results. First, comparing grandmothers and granddaughters, the granddaughters were more likely to be obese, meaning a BMI of greater than 30 kilograms per meter squared. 32% of them versus 9% of them compared to their grandmothers. This reflects the obesity epidemic that we're all aware of. They were also a year younger at menarche than their grandmothers, a median age of 12 instead of 13. And this, of course, has a lifetime health implications that we are mostly aware of: disability, reproductive problems, heart disease, and some cancers over the life course. So here are our results. I'm going to take some time to show this to you. These are the association of the grandmother's perinatal pregnancy-related orthopara DDT with adult granddaughter obesity. And first, I need to say that as we suspected, the findings do depend on whether the grandmother was overweight. And this was a significant finding. This isn't just descriptive. The chance that this grandmother's overweight didn't modify the association with OPDDT on daughter's obesity is small. The p-value is about 3%. So first of all, let's look at that. So here are the findings when the grandmother is not overweight. And remember, this is 1960, and most of the grandmothers were not overweight at this time. 70% of them were not overweight in 1960. It is no longer true, but that's how it was. And this probably applies to most people in the 60s. Fewer people were overweight during pregnancy. So for these individuals, the grandmothers who are in the upper third, the top third of OPDDT compared to the bottom third of OPDDT, the granddaughters had almost approximately a threefold increased risk of being obese themselves, having a BMI of greater than 30 kilograms per meter squared. And it really didn't matter much what other variables we consider. This is correlating with the other forms of DDT we measured. This is correlating with considering the mother's own, the F1 BMI, the mother of these girls. And it also considers the race of the mother. And so this is the first finding that there's a threefold excess risk of obesity in the granddaughters of mothers who had in the granddaughters of grandmothers who had a higher levels of OPDDT in their blood. Let me just remind you, in 1960, everyone had some OPDDT in their blood. The opposite is true for the overweight grandmothers. There's less confidence about what this means, and we have been sort of unwilling to interpret this, but as I said before, we expected the possibility existed for the grandmother's overweight to modify this relationship. So these are the findings for early menarche and OPDDT. Firstly, this association didn't depend on the weight of the grandmother. And so we just have one column of findings here. And basically, regardless of the other variables that we considered, that the granddaughters of the grandmothers who had the higher levels of OPDDT, the top third versus the bottom third, had a twofold increased risk of having menarche in the 25th percentile, meaning before or equal to the age of 11. And this is an interesting finding, and the fact that the grandmother's weight didn't modify this suggests that there's something more complex going on with the grandmother's weight and understanding obesity than for menarche. And we frankly do not know what it is at this time. We need to learn more about how DDT is metabolized and how it behaves in pregnancy and how fat changes the way that happens. So basically, the summary of findings is that in 70% of our 1960s pregnancies where the grandmother wasn't overweight, higher levels of OPDDT was associated with obesity in their granddaughters. That regardless of her weight, the grandmaternal serum of OPDDT during pregnancy was associated with early menarche in her granddaughter. And that these findings weren't explained by the weight or the timing of menarche in the grandmother or mother. So every study has limitations and strengths. I don't have a lot of time, but I'm going to mention some of them. There are other unknown exposures. We are unsure whether OPDDT itself is a toxin or a marker of recent exposure. There are limited representation of Hispanics and Asians in this study, but that is because those individuals were not really living in Alameda County in the 1960s. The strengths of this study are its prospective design, the direct measurement of multiple DDTs in the grandmother perinatal serum at a critical period of potential susceptibility for the gamete and for the embryo, and during active exposure, and the ability to account for the contribution of the grandmother and mother obesity and age at menarche, and representation of Black families who had higher DDT exposures, likely due to migration of families from the South that happened, great urban migration in the 40s, 50s, and continuing into the 60s. So how does this fit into what we already knew about DDT? Well, fortunately, there was a systematic review of this topic recently published, which really helps a great deal, integrating both human and animal studies and in vitro studies, which is a really important thing to do. And they concluded that DDT and DDE, DDT-related compounds, were presumed to be obesogenic in humans based on a moderate level of evidence in these three areas. And I wanted to go through and explain to you the methods for a systemic analysis and why the words presumed and moderate are used in this conclusion. So in a systematic review, you choose before you look at any articles the criteria you're going to use to include them. And you can see this is a lot of work, but if you come down to the bottom, you can see by the time you screen many, many articles, down here, there are 7 human articles that were included. They're prospective, they involve prenatal exposures, and mostly they're related to infant and child health and are done long after the 1960s, where the DDT levels are much lower in the bodies of in the blood of women that are being investigated. For in vivo studies, there are exactly 2. And this points to a limited amount of evidence that points to the need to understand more. And then there are a series of secondary outcomes related to these in vivo studies, which I'll talk about for a minute. And the in vitro studies, which try to understand mechanisms by isolating cells, there were 7. And here were some of the mechanisms and associations that were considered of interest. That DDT seemed to impair or change energy balance, fat cell differentiation, signaling of adipokines that are involved in telling fat cells how to grow, what to do, and how to relate to the rest of the body, lipid abnormalities, and changes in gene expression that are related to obesity and fat. These things are not good, and they are consistent with the findings that we have in that they make them feel and seem more plausible than just association studies. There are also significant gaps in knowledge that I'm not going to go over in detail here because of lack of time, to have you try to understand that despite the fact that this stuff is banned, that there's still a lot we don't understand. And the data that we've shown you today suggests that something that happened 60 years ago is still impacting the lives of people now. And that may mean that even though banned, that there's more work that needs to be done to understand how we might mitigate the effects of these ancestral exposures. So let's put all this together, the granddaughter results together with prior work on DDT in the CHTS. So firstly, without question, the work we've done in CHTS makes it very clear that pregnancy is a critical window of exposure for 3 human generations simultaneously. This was known from animal studies for a while and from what we know about basic biology, but demonstrating it in humans is important because humans we need the confidence that what we think is going on really is. So what we found in the mother's generation, that the levels of her serum DDT in pregnancy were related to her own risk of breast cancer and up to the age of 55, which is the studies we've done so far. This is the mother's generation. In the daughter's generation, we have published on all these findings are published. We have published on the relationship of the mother's DDT and the daughter's change in breast density and risk of breast cancer between the ages of 40 and 52. And in the granddaughters generation, the study we just started to talk about today, that we are talking about today, we have seen the relationship of DDT exposure as measured in the grandmother's serum to the granddaughter's earlier menarche and body mass index at the ages of 18 to 32. This is important as these characteristics, menarche and BMI, are also breast cancer risk factors, but they're also risk factors for other things. Heart disease being one of them, disability, reproductive abnormalities, and a number of others. So here are the takeaway messages. First, exposure to compounds like DDT, which are endocrine disruptors, have the potential for persistent effects on multiple subsequent human generations. This aligns with observations in animal studies. Second, ancestral exposure to endocrine disruptors may impact current generations long after they are banned. And importantly, rather than saying that we're all consigned to a permanent fate, we do believe, I believe, many scientists believe, that mitigation of these kinds of former exposures, generations before, may be possible if we can reveal the mechanisms through transdisciplinary research and find a way to interrupt the pathways that have been disturbed. We all believe this is possible. And finally, the long-term health effects of endocrine disruptors may not be revealed for decades, and therefore, reduction of unnecessary and widespread exposures to such chemicals is certainly warranted to protect the public health. I believe, and many scientists now believe, that we have enough information to be precautionary about chemicals that share some of the characteristics of endocrine disruptors like DDT and others that we know about already. Just a few words about the future of the child health and development studies. This is the only opportunity for 3 and 4 generation research on the impact of environmental chemicals during the critical windows of pregnancy and in the womb. And there are some other studies in the field that 20 or 30 years from now we'll be able to get to these subsequent generations, but they aren't there now. So one of my jobs is to seek funds to make sure this cohort continues, and we enroll the great-grandchildren, that we communicate with cohort members and let them know that they're not replaceable, how important they are, to be able to store biospecimens archive data. If you know of any way that we can secure the cohort with operational funds, please do contact me if you have any ideas or you can help. There are many people to thank. For this study, the California Breast Cancer Research Program, which is a tax checkoff on you, also supported by tax money, Prop 98 money in California, and on your state income tax reform that funded the 3 generations of breast cancer study and a couple of others. We're very grateful. The National Institutes of Health, multiple institutes over 60 years, but mainly NICHD that set this study up in 1959. And the state of California, which creates and supports a number of data resources like the California Cancer Registry, the Vital Status Registry, the Department of Motor Vehicle Files, without which we could not continue to do this work. And a pile of people who have, not all of whom are represented here, and especially these 2 people who are the first co-first authors on the Granddaughters publication that I mentioned, my colleague Pierre Cirillo at CHGS, and Michelle Lamerrill, who is a environmental toxicologist at UC Davis, and many, many other people, including our CHGS Participant Advisory Council. And that, I'll go back because I'd like everyone to see those people, is the end for now. And I want to thank you for inviting me, and I hope that I can answer any questions you might have.
Great, thank you so much, Barbara. Now it's time for our Q&A session. You may type in questions through the Q&A feature available on the menu bar on the top of the window. We'll get to as many comments and questions as we can. Jerry, I'll pass it off to you now if you want to start asking some questions.
Okay, thank you very much. I have to say that was about the clearest presentation of an epidemiology cohort study I've ever heard.
Thank you, Jerry.
That was terrific. A lot of times they get into so much minutia related to epidemiology stuff that you can't get the main points. And I loved how you set that up. Thank you.
Thank you, Jerry.
So here's a couple of questions. We got a lot of them. First one is, did you control for breastfeeding? Do you know anything about that?
Oh, that's a really good question. So in this study, we did not, but we do have breastfeeding information that is kind of minimal in this data set. But I will tell you this, in 1960, we do know that less than 25% or so breastfed at all. And of those who did, it was very minimal. And this was just a matter of fashion. We did control, we can go back and recode those records and take a look. And of course, we don't know about the postnatal exposures to any of these granddaughters because they maybe have been receiving more exposure, from their mothers as they breastfed and also from the environment. And that's, of course, like I said, one of the limitations of the study. But those things would all have come after what we did measure.
Great. So I was really impressed by an odds ratio of 3.6. That seems to me one of the higher levels I've ever heard. Do you know how that fits with some of the other odds ratios for important things like smoking and stuff like that?
Yes, I can tell you. So I can tell you more about breast cancer and our experience with this. So the size of the correlations that we see with DDT and the multiple health outcomes on this study population, now 20 years after having looked at them for testis cancer, for breast cancer in the daughters, for breast cancer in the mothers, are all very large. And also time to pregnancy in the daughters. And I've talked about this with Linda Birnbaum, the former director of NIHS, and other toxicologists and biologists. And what we think is because we are measuring exposure close to a very critical window of susceptibility and development, and we're measuring it really accurately, not retrospectively and not indirectly, asking people whether they used insecticide in their house and they can remember what they used. We think that that is contributing to these really stronger relationships. And there is evidence from our breast cancer study in mothers that as women move away from first exposure at a very young age to first exposure post-puberty, these odds ratios decline considerably. And they're as high as 10 for women who were exposed in utero to DDT, as opposed to dropping down to nothing for at least early breast cancer for women exposed after the age of 14. And I think that's why these odds ratios are so big. I think that the idea of critical period of development is very, very important for understanding what an exposure can do to someone. Smoking is interesting because it also has a long latency, and we suspect a latency also with this exposure that we've published on for breast cancer. And so tobacco is higher, almost higher than anything. It's about 40, I believe, for smokers versus non-smokers.
So when do you think you will have enough great-grandchildren to look at? And what are the important things you'd like to look at there? Everything.
So one of the advantages of this study, I know I'm CHDS is unusual. I'm a little bit unusual because we have the capacity to look at cancer, to look at heart disease, to look at growth and development, to look at reproduction, to look at cognitive function, to look at brain, to look at depression, to look at mental health. And we actually are literally doing all those things. And so the very first thing is to look at the growth and development of those grandchildren, how quickly they develop and mature, whether they're obese, what their cognitive function will be, because, you know, their mothers, and we didn't talk about the father's line. We also need to do that work. We haven't had the money to do it yet, but we want to do it. Their mothers are 20 and 30, so these kids are being born now. And as we now have read in the newspaper, people are delaying their pregnancies. Right now, we know there are already great grandchildren born. We've missed their births. We wish that we hadn't missed their births, but everything I can do, I actually lie awake at night. Every day I know I'm missing something that I need to get to that's not replaceable for another 60 years. So there's something else, Jerry, it's very cool. In California, we archive blood spots when children are born. So there's a way to fill in some exposures that we didn't see directly by requesting and using blood spots that are available on a little piece of filter paper, and from which you can get the exposome, you can get environmental chemicals, but also response. You can get the epigenome, you can get a number of other characteristics. And so that's a marker both of what the fetus was exposed to in utero, and what came across to the newborn's response, but also what was in the mother's blood. We actually are doing some work on this with autism, where we have identified autistic grandchildren, and we're requesting blood spots to see what they were exposed to in utero, even though we couldn't directly observe the pregnancies where they were born. So we're really, we can do this, and nobody else can do it. What it takes is money and commitment. And I hate to be like, I feel like a used car salesman, but without the money, we can't do the work. But I think after the 20 years that we've been working on DDT as sort of a proof of concept exposure, we also look at at the fluorinated compounds and other things, but we know that this yields strong effects because we know we're looking at a really critical period. And generation 4 is not directly exposed to the old things that the first 3 were. And they are the true transgenerational generation on the female line, meaning if we've induced a permanent change in the germ cells that make the next and subsequent generations, we may be able to see them. And I would like to mention, there is this one study on DDT in mouse that shows that this can happen out to 10 generations, I believe he did. But anyway, it's a little bit frightening. It's only one chemical, but we need to know. And we don't think it's like a death sentence. What we want to do is know so we can fix it and or avoid it in the future with the other chemicals that are piling on. I don't know, long answer for nothing. But
okay, there are a lot of questions, but maybe this would be the last one. You know, the more data you have, the more convinced people will be. So are there other biomarkers of exposure or effects that you can measure in addition to like just BMI?
oh yes, absolutely. So we are doing some groundbreaking work on the metabolome with Dean Jones at Emory University and have a number of funded studies. One is to look at disparities in prostate cancer, for example. And the metabolome is a readout of gene by environment interaction. And one of the papers that we've already published in a special issue of reproductive toxicology seems to suggest that there are communities of metabolites, ways that the body responds that are not unique to each chemical, but which are shared by multiple chemicals. And so what we're trying to see is whether there is an internal response to these chemicals that are the real markers of disease risk, so that we might not have to measure 80,000 chemicals, but we might be able to see in a human these biomarkers that are placing people at risk. And this is one of the holy grails. We are working on this. It's doable. We can do this. the new methods that are available in mass spectrometry, the sensitive methods. It's amazing. It's an amazing opportunity.
So one last question, maybe. Using this cohort, I mean, have you ever tried to measure all kinds of chemicals? It would be interesting to know what chemicals were in the people in 1960 compared to today.
Yes, we have. And we know we have a number of answers class by class. We have measured the DDTs and the other pesticides. We've measured polychlorinated biphenyls, which are industrial pollutants, also banned but still around. We've also the perfluorinated compounds. We know, for example, that there's been a great change in the structure of the compounds that was in the grandmothers compared to their daughters, and have published on that reflect the change in manufacture of these chemicals. We actually can go all the way back, and we can even find BPA in the blood of these people, and the chemical cocktail keeps changing. And we're pretty wondering, we think it's very important also to look at the interaction across generation. The pregnancy exposures that happened for the granddaughters, they're different from the gamete exposures for the granddaughters. And we need to see how the piling on of these influences their health going forward. The granddaughters are only 20. We don't know what's going to happen to them. And we need to be able to follow them. And then, of course, their body composition and what they're storing in their bodies is also going to influence their own pregnancies and their great-grandchildren. So it goes on. But I just want to emphasize, most times when you're doing a pregnancy study, if a person says, I don't want to participate, that's too bad, but there'll be another. In our study, these people are irreplaceable because they trace back to an ancestor that we know so much about. Jerry, I wanted to mention something else. We have father's serum. We've only begun to think, grandfather serum. We've only begun to think about what happens on the paternal line, which is extremely interesting to many people for lots of reasons. The sperm are kind of naked, and we are really interested to see how the grandfather's exposures impact all of these outcomes that we just mentioned. And we can do it, but we just haven't done it yet.
Yeah.
And if anyone wants to help me, let me know.
All right. Well, thank you for that, because that was a question that I didn't get to ask. There's another probably 15 questions in here. And for those questions we didn't get to answer, Barbara will answer them and send them to you, or Hannah will tell you how that will work. But anyway, Barbara, thank you so much. This was so interesting. I really appreciate it. Back to you, Hannah.
Okay.
Thank you so much, Barbara, and Jerry too, for moderating. We're approaching the end of today's webinar. A video recording will be available on CHE's website soon, and tomorrow you'll receive an email containing a link to the video. Our next CHE EDC Strategies Partnership webinar will take place on July 15th and is the fourth in our ongoing series, PFAS Science and Policy. This webinar will feature Erica Schurter, Lori Valeriano, and Scott Belcher's research looking at PFAS in animals and human breast milk and concerning trends for current use. Details will be posted shortly on our website at healthandenvironment.org. If you are new to CHE and would like to stay updated about community events or more, please sign up to receive our newsletter by selecting the Join Us tab at the top of any page on our website at healthandenvironment.org. Additionally, if you appreciate these CHE partnership webinars bringing the latest environmental health research for free, we encourage you to support CHE's ongoing work by making a tax-deductible donation via our secure website. Again, our website is healthandenvironment.org. With that, I would like to thank you, Barbara, for taking time today to present, and to you, Jerry, for your excellent moderation. We'll get to as many comments or questions as we can. I'll send them off to Barbara and see what we can do as she has time. And I want to thank everybody, wishing everybody much health and wellness, and we'll be in touch and hope to see you next time.